Hi, everyone. Ni hao. Thank you for coming. Today, we're going to talk about what it's going to take our industry to the next level and to have it change the way the world works even faster. I see the world as really being divided into two key categories of activity: the probabilistic activity and the deterministic activity. Probabilistic activity is what brands do. Brands create promises that are backed by legal systems, and those brand promises are then followed through on or not followed through on at the discretion of the brand, right? And you can think of this as centralization, or you could consider these institutions. You can consider them, whatever version of the term you'd like. But brands and centralized institutions are kind of the same thing. Now, these centralized institutions try to fulfill their obligations, but in many cases, they cannot, and in some malicious cases, they plan not to. This probabilistic world where we can't rely on brands and institutions to follow through is basically the previous world. The future world is the deterministic world. In the deterministic world, mathematical formulas determine what happens. This is really what Bitcoin and various other tokens began, is they allowed people to use private keys to engage in ownership in a deterministic way. And this deterministic ownership gave rise to our industry and the value held within our industry. Since then, as many of you know, we've expanded what our industry does to smart contracts, whether those are DeFi contracts or insurance contracts or many other types. But at the end of the day, what we're really talking about is creating a highly deterministic and mathematically guaranteed set of interactions. This is the big shift that our industry is about and that our body of work on Chainlink is really focused on. It's fundamentally taking how system works from a place where brands and individual institutions can control everything to a place where cryptographic guarantees and mathematical certainty gives people reliable, basically relationships with peers or relationships with those same institutions. But now those relationships are mathematically guaranteed. They will always be followed through on as long as mathematics and encryption functions as it does. And this is a very common pattern already with Web 2, where systems that are unable to fulfill their obligations just as a brand often add encryption and what we call trust minimization guarantees to win back their users' faith in them. This has happened in the West through the use of apps like WhatsApp and Signal and others. And I know encryption is more and more popular all over the world to guarantee the integrity and privacy of messages. And this is because the systems that transmit the messages without encryption began to become less and less trusted. So the way that we all arrive at a world where we can rely on each other as peers and we can rely on institutions to follow through on their commitments is a world where those relationships are cryptographically guaranteed. And those cryptographic guarantees are, once again, what I think our entire industry does, and it's what we focus on doing in our work on Chainlink. This universe for cryptographically guaranteed, trust minimized applications right now is hovering in the 1 trillion mark. It's gone as high as 2.5 trillion. And it's really right now focused on blockchains and smart contracts. But our very strong belief is that the entire world's value, whether that's derivatives value, real estate value, equity value, global trade, global advertising, insurance, even commodity ownership, will eventually extend into the world of trust minimized apps. Because fundamentally, if you have a trust minimized application and you have a Web 2 application that isn't trust minimized, there really is no case where somebody would choose the Web 2 application, right? So if I gave you the exact same digital agreement, the exact same internet-based interaction, and that internet-based interaction was in one case not guaranteed, and in another case fully guaranteed, you would always take the fully guaranteed interaction as long as the speed, cost, and other properties were all the same. So really, when you look at what our industry and what the entire trust minimization industry, which is coming out of blockchains and smart contracts, is about, it's really about creating those highly reliable relationships for all value and all transactions, everything from ownership to smart contracts about financial products to global trade to everything else. And when you create this world, it does two very important things. It allows people locally to rely on each other, but it also allows people to rely on each other internationally, so that local legal systems don't need to be relied on as much. And the interaction between entities, even across borders and even across languages and even across legal systems, can become highly, highly guaranteed. This is one of these are the two main reasons that the vast majority of the world's value over the coming years will become trust minimized. And the vast majority of that trust minimization will happen through blockchains, oracle networks, and decentralized infrastructure generally. What we provide in our work on Chainlink is something called an oracle network. An oracle network is a system that sits in parallel to a blockchain, and this parallel system creates consensus and various trust minimization guarantees about all the topics that a blockchain can't create those guarantees for, but needs trust minimization about. So blockchains are very good at creating trust minimization about private key signatures, token ledgers, and state machines, where the if-then conditions of contracts are largely defined. Oracle networks are able to create trust minimized guarantees about everything else. They create trust minimization about market data, identity data, proof of reserves, and really all kinds of other data. Now we've been able to expand what the Chainlink network does into the realm of computation, creating one of the most widely used random number generators in the entire blockchain industry, and in some specific chains, the most widely used source of randomness in those environments. We've also added the ability to do automation through something called keepers, and we're continuing to expand the computational capability of Oracle networks. We also have great plans for a cross-chain system that's going to allow chains to communicate between each other with the same high quality of trust minimization guarantees as the trust minimization that secures huge amounts of data and the trust minimization that secures the randomness and automation that powers many applications. Generally speaking, Oracle networks are responsible for allowing DeFi to grow into what it is by providing the data without which DeFi wouldn't be able to exist and couldn't function without. So the first thing that Oracle networks were applied to successfully by Chainlink, and really what I would say we pioneered, is the ability to have hundreds and eventually, thousands of Oracle networks that can generate specific pieces of truth on specific topics, such as market data, weather data, identity data, or all types of other data. Obviously, when you make applications, those applications are driven by data. So more advanced applications need data. And that is really what the Chainlink network provides. And that's really what we are focused on initially providing to the blockchain ecosystem, is verified data from multiple different sources, whether that's price data, weather data, proof of an asset's state to create real-world assets represented on chain, or many other categories of data. Computation is the second category, and cross-chain is the third. All of these three categories rely very heavily on the Oracle network's ability to provide highly reliable computation and to do it in a trust minimized way that's previously not possible and only became possible with the help of Oracle networks. In providing the largest amount of on-chain data ever, we've given rise to the ability for DeFi to come to life, because the data sets that we've put on a vast amount of different chains is what has allowed DeFi to come into existence. And that's why Chainlink is so well known and so connected to DeFi. But in fact, these data points include other data points about weather or identity or any other types of data. And so it actually expands far beyond DeFi. We've also been able to help create a system together with our community that can scale and has already scaled to over 1,000 distinct Oracle networks. So just like you hear many chains talking about scaling by creating subnets or shards or smaller versions of the chain that are connected to a larger chain, we have successfully already been able to achieve that for Oracle networks on the order of over 1,000 Oracle networks. In achieving that for over 1,000 Oracle networks, we've learned a lot of valuable lessons that has made the protocol better and allows us to continue to make greater and greater amounts of Oracle networks on a greater and greater variety of topics. But if you really think about it, I think you'll see that while things may have started with people seeing a monolithic single chain architecture where everything would be on a single chain, there is now more and more of a movement towards multiple different smaller chains and even individual app chains where a single app is connected to its own unique chain for that app. We actually already see multiple smart contracts using multiple Chainlink services at the same time. And so what Chainlink services and these many Oracle networks are actually distinct singular computations run in their own individual decentralized environment. And that individual decentralized environment then becomes connected with smart contracts to make more advanced applications. The fact that we can scale this to over 1,000 distinct committees, over 1,000 distinct networks, shows that Oracle networks have already achieved the level of scalability that many blockchains are only starting to try to approach by making many smaller versions of themselves. We've also had huge adoption of these Oracle networks by over 1,500 various projects, whether those projects are providing data, using data, or interacting with the networks in some other way. This massive growth in and of itself shows the extreme value of Oracle networks in enabling not only the connection of data to smart contracts, but also the ability for Oracle networks to do much more in the form of computation, and sometimes soon in the form of cross-chain communications and cross-chain token interactions. The fact that there's an increasing amount of public GitHub repos, which is one metric of measuring the adoption of something, and that continual increase only continues to grow steeper, is another clear sign that Oracle networks are a key property of how more advanced smart contracts are built. And we fully expect that as more and more advanced smart contracts get built, and as more and more advanced trust minimized applications come into existence, they will rely on Oracle networks, whether or not they run on a blockchain. So trust minimized applications in some cases can run in a Web2 server, in some cases on a blockchain, but in any case, they will definitely need trust minimized inputs, such as data, random numbers, and other categories of trust minimized Oracle-based inputs. Where all of this is going is the ability for decentralized services to grow the initial universe of trust minimized apps. And once again, that's what we have become very well known for doing in DeFi. And that's what we continue to do in many other verticals, whether that's insurance or gaming or other categories. But the ability to build an entirely new application because you have a multitude of inputs that you didn't have before is something we see many, many application developers taking advantage of even today. So we have multiple applications that utilize us for data, randomness, and various other compute functions, and that have already discussed utilizing the Chainlink network for cross-chain communications and token movements. So this universe of computation in the form of an Oracle network is really the more specific, more focused, more, in many ways, scalable version of decentralized computation that solves very specific problems, allowing for smart contracts to do more and for trust minimized applications and categories of trust minimized applications to come into existence. We see the initial use of Oracle networks as a cryptographic truth source on many different topics, whether that's a computation, a random number generation, a data source, an aggregation of data sources, identity data, or any other number of inputs. And once again, we're already seeing multiple applications using multiple different Oracle networks at the same time in what is called the services-oriented architecture, which basically shows that, yes, people can write smart contracts in specific chains, but as they write those smart contracts, they need multiple different Oracle networks to make them come to life and do something more useful. The next stage, in addition to those services, is really as Chainlink as an abstraction layer, as a place where backend systems and various smart contracts can interact with each other. So whether you want to send a command from an existing infrastructure like a Web2 backend or an enterprise backend, or whether you want multiple smart contracts to interact with each other while consuming those services, you should be able to do that through one standard in the form of something called CCIP, the Cross-Chain Interoperability Protocol, which focuses on messaging and focuses on creating interactions both between smart contracts on different chains and between backend existing web systems. So while we have began to put large amounts of data, large amounts of events into smart contracts successfully, and as you saw in the previous graphs, we've reached historical levels of doing that both in the amount of data and the scale and the adoption of that data. Now we are expanding to allow that transmission of events and commands to extend to existing backends. So if you've built a Web 2 application or an enterprise application and you want to interact with multiple contracts on multiple chains, you should have a single simple interface to abstract away the complexity of chains and allow you to interact with multiple chains, whether that's for triggering those contracts, understanding them, stringing them together into a more advanced trust minimized application. All of that should happen through an environment that allows you to interact with multiple contracts and allows your existing infrastructure to interface with those contracts for a multitude of different topics. So our goal is not only to create a trust minimized decentralized services universe, which is something we've already been able to do at scale with over 1,000 Oracle networks, looking to expand from there to multitudes and multitudes more networks. We also see the value in providing that connection between existing systems for all control of all contracts across all chains and the interaction between contracts and chains. This is something that's going to allow the mainstream and the Web 2 world to more efficiently use blockchains to create their version of a trust minimized application, because the trust minimized application really lives on a spectrum where you have a multitude of different ways to make something trust minimized. So you can make it fully trust minimized by rewriting your application in a blockchain. You can make it partially trust minimized by making part of it controlled by a Web 2 server and part of it controlled on chain, or you can make it minimally trust minimized by making it mostly controlled by a Web 2 or an enterprise system, but key parts of the application are now represented on chain. And this is really the spectrum that we hope to enable for enterprise, Web 2, Web 3, all developers across all categories of applications, so that they can build the version of a trust minimized application that's most applicable to them. This will require them to use blockchains. It will require them to use oracles, but really the flexibility of allowing people to build whatever degree of trust minimization they want to build into their application is really the fundamental goal. This shift to a trust minimized world will require what we call truth infrastructure. And fundamentally, I think all cryptographic systems create truth infrastructure. So they create infrastructure that guarantees relationships by signing things and creating a certain truth about either who wants to do something via a private key or an aggregation of multiple events via an Oracle network, or any number of other cryptographically guaranteed relationships. Generally speaking, the ability for us to help create truth infrastructure and the ability for that truth infrastructure to enable more and more trust minimized applications is what I believe will lead to a cryptographically guaranteed society. So the cryptographically guaranteed society is what we spoke about at the beginning of the presentation, where people no longer need to rely on brand guarantees or legal guarantees or other types of promises that might not be fulfilled. They don't necessarily need to know each other. They don't need to speak the same language. They don't need to be in the same legal system, but they can interact with each other in an extremely reliable, cryptographically guaranteed way. And this cryptographically guaranteed society is far superior. Now, this is what's all the way to the right on this diagram, and it's something that, we're going to strive to achieve over the course of many, many years. It begins with trust minimized applications being enabled on blockchains, starting with ownership through private keys and tokens, moving on to DeFi and financial products, and then moving on to all mainstream use cases, everything from ad networks to ticket sales, to global trade, to ownership of equities, to derivatives, to any number of other categories. Eventually, trust minimized applications will be the minimum. So there will be a fundamental demand for people to use trust minimized applications as their minimum for interacting with peers and interacting with institutions. Similarly to how the new minimum for people to interact with information is the internet. It isn't by paper and it isn't by voice. It's through sending things through the internet, right? Sending information through the internet. So this is really the revolution I think we're all a part of. I think the Chainlink network has a very key, very specific role to play, which is enabling these trust minimized applications to come to life on blockchains, then creating a very large, very well integrated abstraction layer that allows everything from banks to insurance companies to global trade systems to ad networks to all existing systems to interact with all blockchains and to get the trust minimized inputs that they need from the Oracle networks that are running within the Chainlink network and creating a large economy of their own. And then all of this will accelerate the rate at which we arrive at a cryptographically guaranteed society. And that is really the society that I think we're all working towards in this industry, one where we can all rely on each other on the basis of mathematics and deterministic guarantees. I think it's a very exciting future, and I'm thrilled to have you here at the conference, and I appreciate you thinking through this with us and listening to the talk. I wish you all the best. Xie xie, and have a great rest of the conference.